Namaste student, welcome to class chemistry. Today I am going to explain dual nature of electrons. Now Max Planck, he explained that, or he proved that light or radiations has a particle property. That means according to his point of view, radiations are made up of tiny particles, made up of very small particles, and this tiny packet of energy are called as a photon or a quanta. So according to him, that means Max Planck, he proved that, or he told that light radiations or light are made up of tiny packets of energy. These packets of energy are called as a photon or a quanta. Okay, so according to him, light is made up of a small particles. Okay, but before proving light is a particle, before that it was considered as a wave. Light is a wave. Okay, so finally other scientists, okay, they did the so many experiment, and finally scientists are proved that light has a dual nature. What is the meaning of dual nature? The word itself, it tells that dual means two. Okay, so that means light has a two types of nature. That is, light has both wave as well as a particle properties. Okay, so the concept, this concept is regarding light, but here the same concept is applied to the electron also. The scientist called as a de Broglie, scientist called as a de Broglie, he proved dual nature of electrons. Okay, you can see the picture of the de Broglie. Now this is called as a de Broglie hypothesis. Now what is the meaning of hypothesis? Hypothesis means it is not a principle or it is not a postulate. Hypothesis means it is nothing but just a suggestion, or he has given an idea. He has given an idea. Okay, now according to him, what is his hypothesis? According to de Broglie, he explained that, or he has given an idea that electron has a dual nature. Even electron has a dual nature like light. That is, electron has both wave nature as well as a particle nature. Okay, that means electron is associated with the momentum. If wave nature is there, means it should be a wavelength. If particle nature is there, means there should be a momentum. That means electron is associated with the momentum as well as a wavelength. Okay, so now what he, according to the statement, he put forth one equation. Okay, if electron, that means if electron is considered as a particle, then it should have a mass. Okay, if electron is considered as a particle, then it should has a mass. Now what is the mass of electron? That is 9.1 into 10 to the power minus 31 kg. If electron is considered as a wave, then it should have a speed. Okay, so what is the velocity of electron? It is 2.18 into 10 to the power 6 meter per second. Okay, so if electron is wave, then it should have a wavelength. What is a wavelength symbol? Lambda. Okay, I will repeat it again. If suppose if electron is considered as a particle, now it is already told that what he told de Broglie, what he has given the idea, he suggested that electron has both wave nature as well as a particle nature. Suppose electron is considered as a particle, then it should have a mass. Okay, what is the mass of electron? That is 9.1 into 10 to the power, here you can see 9.1 into 10 to the power minus 31 kg. Okay, if electron is considered as a wave, then it should have a speed. What is the speed or velocity of electron? That is 2.18 into 10 to the power 6 meter per second. If electron is wave, then electron should has a wavelength. If electron is a wave, then it should has a wavelength. Okay, if electron is considered as a particle, then it should have a mass and velocity together. So mass and velocity together, it is called as a momentum. Okay, so based on these ideas, he put forth one equation, okay, or relationship, that is lambda is equal to h by mv. Lambda is equal to h by mv, or it is also written as h by p, where m into v, it is also called as a momentum, that is a p. Okay, so it is a m into v, that is called as a p. P means it is nothing but a momentum. Okay, so lambda means it is a wavelength, and m into v means it is nothing but a momentum. So I hope you understood the concept. I will repeat it again. De Broglie hypothesis. Now hypothesis means it is just giving an idea, or he just gave a suggestion. Okay, now what he suggested, that electron has a dual nature, that is it has both wave nature as well as a particle nature. So since it has a wave nature as well as a particle nature, of course the electron is associated with the momentum as well as a wavelength. That means, suppose if electron is considered as a particle, ಒಂದು ವೇಳೆ electron ಅನ್ನು particle ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ಏನಿರಬೇಕು, ಮಾಸ್ ಇರಬೇಕು. ಸೊ ವಾಟ್ ಇಸ್ ಅ ಮಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್? 9.1 into 10 to the power minus 31 kg. If electron is considered as a wave, ಒಂದು ವೇಳೆ electron ಅನ್ನು wave ಅಂತ ಹೇಳಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, it should has a speed, that is 2.18 into 10 to the power 6 meter per second. Okay, if electron is a wave, then what is a characteristic of wave? Of course wavelength should be there. Okay, fundamental characteristic of wave is the one fundamental characteristic of wave is it is nothing but a wavelength. If electron is considered as a particle, of course particle means there should be a mass and velocity. Okay, mass and velocity together, it is called as a momentum. So based on these ideas, he gave a relationship between wavelength and a momentum, that is lambda is equal to h by mv, or that is also written as h by p. Okay, so this equation is very important for the sake of exam. Usually questions are asked either for 3 marks or for 2 marks. Okay, explain de Broglie hypothesis and write the equation. Okay, now next one. Now what he told, that is a electron. Electron is a moving particle. So all moving particles have a dual nature. Of course all moving particles have a dual nature. Okay, dual nature means wave nature and particle nature. Now we'll give suppose if I take the example, cricket ball, that is also moving particle. Electron, I am comparing with the cricket ball and electron. Electron is also moving particle. Now see, imagine cricket ball has a mass 100 gram, velocity or speed it is a 20 meter per second. This is the imaginary value. Okay, that value you just substitute in a equation, that is given by de Broglie. Lambda is equal to h by mv. Here you can see the calculation. Okay, what is answer you will get? That is a lambda is equal to 3.313 into 10 to the power minus 24 Armstrong. Minus 24 Armstrong means it is nothing but a values in 0.000. Okay, same way in another side, you just see the electron concept. Mass is 9.1 into 10 to the power minus 31. Velocity is 2.1 into 10 to the power 6 meter per second. Substitute all these values to the de Broglie equation. What is the answer you will get? It is a lambda is equal to 3.2 Armstrong. So what is the difference between these two? Cricket ball wavelength you will get, that is in a 0.00 answers, because it is a value, it is in the form of 10 to the power minus 24. But in the case of electron, you will get wavelength lambda is equal to 3.2 Armstrong. Okay, now that means moving cricket ball has a very small wavelength. It cannot be measured. Cannot be measured. Okay, moving cricket ball has a very small wavelength. You will get an answer in the form of 0.00003, because the values are in the form of 10 to the power minus 24. Okay, so it is very small. It cannot be measured at all. So based on that, what we are saying, this hypothesis valid only for the microscopic moving particles, not for the macroscopic moving particles, only for the microscopical. De Broglie hypothesis applicable only the microscopic moving particle, not applicable to macroscopical moving particles. Now cricket ball is a macroscopic. Macroscopic means it is a big. Okay, electron, it is a microscopic, you can't see. Okay, it is a very small particle. So this hypothesis only for the which one, microscopical moving particles, not for the big object, not for the big object. Okay, I hope you understood the concept about de Broglie. So what is a statement? What you can say? That is all according to de Broglie hypothesis, what he told or what he suggested, all microscopic moving particles have dual nature, that is wave nature as well as a particle nature. So all microscopic moving particles means, since it is a chemistry, so of course I have to use a term called as a electron. So electron has a dual nature, that is wave nature as well as a particle nature. Now we'll move on to the next term, Heisenberg's uncertainty principle. Heisenberg uncertainty principle. So you can see the picture of Heisenberg. Okay, now what he told, what is a principle? Now according to him, it is impossible to determine exact position as well as exact momentum. Exact position, that means it is a place, and exact momentum of moving subatomic particles like electron simultaneously. That means at a time both exact position as well as the exact momentum of the microscopic particles, that is electron, it is microscopic particle means moving microscopic particles like electron, it is impossible to calculate simultaneously, or at the same time it is not possible to determine or find exact position and exact momentum of moving microscopic particles like electron. It is not possible at all. Okay, we can't calculate exact or accurate value of position. Okay, position of the electron, moving electron, or momentum of the moving electron, it is not possible to find or measure. Okay, imagine that if you know mass of the electron as well as velocity of electron, you can't find exact place of electron. You can't find exact place of electron. It may anywhere. Okay, same way, imagine that if you know the position or place of the electron, it is not possible to calculate mass and velocity of the electron. So simultaneously both we cannot find out. Okay, so this is called as a Heisenberg uncertainty principle. Okay, now here he put forth an equation, that what he told, okay, error in measurement of the momentum. It is already told that it is not possible to find the exact or actual momentum. So that's why we are using the word error in measurement. Okay, error in measurement of the momentum, it is referred as, or it is given as a delta P. So you can see the mathematical expression here. You can see the mathematical expression, this one. Okay, now error in measurement of the momentum, that is a delta P. Okay, and error in measurement of the position, that is delta X. Okay, the product of these multiplication, it is written in between delta X and delta P. So product of these two, it is always either more than h by 4 pi or equal to h by 4 pi. That means you will not get a value as a 0. 0 means, what is the meaning of 0 value? You will never get a value as a 0. Product of delta p and delta x, you will never get 0. That means if you get 0 means this principle is not at all valid. Okay, so that means a product of these errors, either it is more or equal to h by 4 pi. Okay, so this concept is very important. That is what is a Heisenberg uncertainty principle. It is impossible to determine. That means it is not at all possible, or it is we cannot determine, or we cannot find exact position and exact momentum of moving subatomic particle like electron simultaneously. That means at a time. Okay, so what is a mathematical expression of Heisenberg uncertainty principle? Delta x into delta p, that is a product of measurement of position, error in measurement of position and error in measurement of momentum. It is either more than or equal to h by 4 pi. You will never get a 0 answer. If you get a 0 means there is no error, but you will never get a 0 value. Okay, so now what is the significance of uncertainty principle? Here this is applicable here also. This is applicable only for the microscopic object, not for the macroscopic object. Okay, so this is one of the drawback of the Bohr model. Bohr model, now Bohr, what he explained, Bohr considered that electron is a moving particle. Okay, moving particle, consider as a electron is a moving particle, but later scientists explained or proved that electron not only a particle, even it explains the wave nature of wave nature. Okay, wave properties. Now Bohr measured position of the electron and velocity of electron, but Heisenberg, what he told that it is not possible to measure a position and momentum of electron, moving electron simultaneously. It is not at all possible. Okay, so this Heisenberg uncertainty goes against Bohr's atomic model. Okay, now next topic. That is very important topic, and it okay, usually questions are asked for 4 marks. That is a quantum mechanical model of atom. Okay, now here this quantum mechanics developed by Werner Heisenberg and Erwin Schrödinger. You can see the picture of Werner Heisenberg and Erwin Schrödinger. Okay, now Schrödinger, he gave equation. This quantum mechanics, it is also called as a wave mechanical model of atom. Okay, wave mechanical model of atom. Now quantum means it is nothing but a very small particles. Okay, this model shows that electron is a matter wave. This model shows that electron is a matter wave. Okay, now Schrödinger discovered an equation that is called as a Schrödinger wave equation. He gave equation for the wave property of electron. Okay, he gave an equation for the wave property of electron. Now equation, you can see the equation. You can see the equation, but this equation is not there in the syllabus. Okay, these equation or solution of Schrödinger wave equation, solution of Schrödinger wave equation gives or gave 3 variables. Solution to Schrödinger electron wave equation gave 3 variables which represents position of electron, which represents position of electrons. That is that means it is a position means the probability of finding of electron is a maximum. That is the position where probability of finding of electron is a maximum. Okay, so these Schrödinger wave equation gives 3 variables. These 3 variables are called as 3 quantum numbers. Okay, these equations are not at all important. It is not there in the syllabus. just have given an idea based on the wave equation. Okay, Schrodinger gave a equation for the wave property of electron. Based on these equation, it gave three variables. Okay, these three variables are called as three quantum numbers. Okay, these three variables are called as three quantum numbers. Now actually in a simple manner I can call it as, it is nothing but the address of the electron, or a status of the electron, where it is present, like that. Suppose if someone asks the address, what you will say? My house is in Mangalore. Okay, in Mangalore you are in Tokkot, you are in Permanur, like that you will go in to the deep. So same way quantum mechanics, it gives the information about the electrons, okay, or address of the electrons or status of the electron. Okay, or I can call it as, it explains the location of a electron or a probability of finding of a electron. Now we'll read one by one. Quantum numbers, it explains the concept of atomic orbitals. Okay, now atomic orbitals are distinguished with the help of three quantum numbers called principal quantum number, azimuthal quantum number, and magnetic quantum numbers. Before explaining these three quantum numbers, I will explain what is the meaning of atomic orbitals and what is the difference between orbit and orbitals. Okay, now atomic orbitals or orbitals, it is a three-dimensional region in space around the nucleus in which the probability of finding an electron is maximum. Okay, I will repeat the definition. The meaning of orbital, it is a three-dimensional region. It is a 3D, three-dimensional region in a space around the nucleus in which the probability of finding an electron is maximum. Now, what is the meaning of orbit? Orbit concept is given by Niels Bohr. He already explained what is the meaning of orbit or shell, one and the same. Now here orbit means it is nothing but just a circular path. It's just a circular path around the nucleus in which the electron revolves. Okay, it is just a circular path. It is just a circular path around the nucleus in which the electron revolves. Now here you can watch it properly. Okay, it is just a circular path around the nucleus in which electron revolves. But in the case of orbital, you can see here it is nothing but a three-dimensional region in a space around the nucleus in which probability of finding electron is maximum. See, you can see the axis, x-axis, y-axis, z-axis, and different shapes and all you can observe. Okay, now what is one more difference? Orbit, it represents the movement of electron in one plane. It represents the movement of electron in only one plane, that is only in the circular movement path. Okay, but in the case of orbital, it is nothing but a three-dimensional space. Three-dimensional space means orientation of electron, it is according to the x-axis, y-axis, and z-axis. So it represents the three-dimensional space around in the nucleus. Okay, now in the case of orbit, its shape is circular. In the case of orbit, its shape is circular, but in the case of orbital, its shape depends on the quantum number. Its shape depends on the quantum number value, azimuthal quantum number value. That means it can be spherical, double dumbbell shape, or a complex shape. Here you can see that is a dumbbell shape, a double dumbbell shape. This is a complex shape. Okay, so different shapes you can identify in the case of orbital, but in the case of orbit there is only one circular shape. Okay, orbit have no directional characteristics. Actually, in the case of orbit, it is just a circular path. There is no directional characteristics. But in the case of a orbital, except s orbital it is in a spherical shape, but in other p orbital, d orbital and f orbital, it has it has a directional characteristics like x axis, y axis and z axis. Okay, in the case of an orbit can accommodate maximum of 2n square of electrons, where n is the order of orbit from the nucleus. In the case of orbital, it accommodate maximum of only 2 electrons, but in the case of orbit it is a 2n square of electrons. Okay, 2n square of electrons. Orbital can accommodate only maximum 2 electrons, Okay, so I will repeat what are the difference between orbit and orbital. Orbit, it is nothing but electrons move in a circular path around the nucleus. Okay, and movement of electron in one plane. Then orbit have no directional characteristics. Okay, and orbit accommodate 2n square of electrons. Okay, 2n square of electrons. But in the case of orbital it is nothing but a three-dimensional region in space around the nucleus, in which probability of finding electron is maximum, and it represents a three-dimensional space, direction, and it helps to tells about the shape of the orbital. It may be spherical shape, dumbbell shape, or double shape, or complex shape. Okay, orbital, except s orbital, other have directional characteristics. That is p, d and f orbital have a directional characteristics. Okay, and this orbital accommodate a maximum of only 2 electrons. Now you can see the shape of the atomic orbitals. Okay, here it is s orbital. It is spherical in shape. Okay, it is spherical in shape. P orbital, it is dumbbell in shape, and d orbitals, it is a double in shape. Okay, f orbitals, actually it is a complex. It has a complex shape. Here you can watch properly. S orbital, p orbital, d orbital and f orbital, it has a complex shape. Okay, in the p orbital 2 lobes are there. You can see here 2 lobes. In the d orbital it is 4 lobes, but in the f orbitals total it is 8 lobes. Here you can watch it properly. Okay, here only one face is given, backside face is not given. So here it is 8 lobes are present. It is a complex shape. Okay, then still p orbitals, I already told that except s orbital, the remaining other p, d and f orbitals are directional. Okay, so here you can see if dumbbell shape are oriented towards the x-axis, this is x-axis, then it is called as a px orbital. Okay, and if it is oriented along the y direction, then it is called as a py orbital. If it is oriented towards the z axis, it is a 2p z orbital. Okay, this is about the p orbitals. So p orbitals has a px, py and pz based on the orientation according to the axis. Now this is a d orbitals. D has 5 d orbitals. Okay, that is lobes, since it is a double, lobes are present between the x and y, so then it is called as a dxy. If it is lobes present between the y and z, okay, lobes present between the y and z axis, then it is called as a dyz, and lobes, if it is present between the x and s, then it is called as a dxz. If lobes are on the x and y axis, then it is called as a d of x square minus y square. Okay, and here you can watch it. Lobes are both the double lobes are overlapped on the z axis itself. Okay, so this is called as a dz square. So these are the arrangement. Here also this is about the See here also you can watch it. This is about the d, okay, d orbital, how it is arranged, the lobes in between the axis, and two are on the axis. Here dx square minus y square, that means lobes are oriented along the axis. Here also dz square means lobes are on the z axis. Okay, now this is f orbitals. F, there are 7. 1 2 3, yeah, it is a 7. Okay, now you can see this is a complex shape. So these are the arrangement.